Welcome to the SAFECode e-learning course, Basic Practices for Secure Development of Cloud Applications 101, Part 2. The goal of this course is to provide you with essential information about secure development of cloud applications. At the end of this part of the course, you will have a more detailed understanding of what the shared security responsibilities between you and the CSP contain, and you will be able to start assessing your cloud environments in order to mitigate associated cloud-related risks. We will also provide you with additional resources to extend and improve your cloud application knowledge. The primary audience for the course are software and system architects as well as product and program managers. Again, other parties involved in the software development process of cloud applications will benefit from it as well, as having an understanding of the threats that a cloud application might face and how to split responsibilities between you and the CSP is helpful from the very beginning of the development lifecycle. For this course, we recommend that you already have a basic idea of what a cloud system is, how it works, and what the most common threats for a cloud system are. If you would like to brush up your knowledge on this, we recommend to first watch the training Basic Practices for Secure Development of Cloud Applications 101, Part 1, and then come back to this video. While the first part of this training ended with discussing the shared responsibilities briefly, the second part explores more deeply how the responsibilities are shared between cloud service provider and the customer security-wise. Finally, we finish this course with a 10-step guide on how to assess cloud-based applications for security, to help you with taking the first essential steps on assessing your own cloud applications. Let's begin this lesson with a closer look at shared responsibilities and the technical background you need to secure your application with these responsibilities. For those of you who have taken the first part of the course already, this will be a short refresher before going into further details. This diagram shows who is responsible for which security topic on which cloud model. Now, let's go step by step through the diagram to dive into the details of every topic. On the top row, you see the deployment models that we defined and discussed before, namely on-premise, infrastructure as a service, platform as a service, and software as a service. On the leftmost column, we have depicted the different responsibilities for a cloud environment, starting with data classification and accountability and going down to physical security. We will discuss each of the responsibilities in detail. Feel free to jump back to this slide later or pause the training if you would like to study this overview diagram longer. The first topic is data classification and accountability. In all cloud models, it is the customer's sole responsibility to label and classify all his data. This can be a very complex process, but it is important to distinguish which kind of data must be stored in the cloud securely. Sensitive data such as health information and credit card numbers should not be made public or stored in any public cloud. If this can't be avoided, the most common recommendation is to protect sensitive data as good as possible and to keep an eye on where it resides. One way to do this is via encryption, allowing only authorized entities or applications with the right key to extract the information. But there is another approach, which removes sensitive data from systems where it does not need to exist or disassociates the data from its sensitive context. This technique is called tokenization, and it originates in the payment card industry. Tokenization replaces the sensitive data with a value, a so-called token. All the sensitive data is stored in a secure central system, where authorized applications can exchange tokens to process and work with the information. With this technique, the risk of sensitive data exposure can be decreased. As an additional benefit, fewer systems need to comply with data protection requirements when using tokenization. Tokens, however, must be generated in a secure procedure, so there is no way to recover the sensitive information from the token. As we are touching confidentiality of data already, let's jump into privacy policies next. When using a cloud provider, it may be mandatory, depending on processed data, to enforce some kind of privacy policies. Privacy relates to the storage and use of personally identifiable information, or short, PI. Depending on country and nation, different laws and regulations exist for PI. Cloud service customers must evaluate if they intend to store or process any kind of PI inside the cloud service. All privacy-related issues need to be addressed within the cloud service contract and service level agreement. It should be clear who is responsible for what and which jurisdictions are involved. Depending on the used cloud service, the responsibilities will vary. In case of an IaaS, the cloud provider will be unaware of the data which is stored and used within the customer's virtual machine. Therefore, all responsibilities lie with the customer to ensure the enforcement of the appropriate privacy policies. If a SaaS application works with Pi, then it is within the responsibility of the cloud service provider to enforce appropriate protection of the Pi within the service. The use of encryption for any kind of data storage, suitable access control, database activity monitoring, as well as database vulnerability scanning are measures which cloud providers should enforce. In 2014, the ISO standard 27018 was released, which extended the established ISO 27002 security standard to deal explicitly with the handling of Pi in the context of cloud computing. As a cloud service customer, it is therefore possible to request your cloud service provider to demonstrate their conformance to this standard, and also you as an application owner relying on cloud services may be requested to adhere to the requirements of this standard. Next, at least for a short discussion, we will focus on client and endpoint protection. Because more and more devices are connected to the cloud, it is very important to have defined boundaries and defined responsibilities for all these devices. Remember that not only server systems are needed to operate and manage a cloud, but also client systems. To protect from attacks coming from clients and endpoints, endpoint device management systems are something that should be considered. Think about the worst case, that the clients used for accessing the management interface of a CSP are compromised. Also, remember that attackers increasingly have started to target admin users through spear phishing attacks for this exact reason. It is therefore advisable to keep an eye on the security of critical endpoints as well. Let's continue with identity and access management. It provides users the ability to access and use resources in their environment, and it is the link between the who and the what. There are shared responsibilities in the PaaS and SaaS cloud model when it comes to identity and access management. Authentication methods of a cloud application should be seen from different points of views. On the one hand, the application as an authentication customer authenticates itself against the PaaS to get access to provided services and interfaces. On the other hand, the application as an authentication provider authenticates the user against the application. This means that an application needs to support multiple authentication methods. To identify a user in a cloud application, the source of identity is playing a key role. To authenticate against a PaaS, the PaaS provider usually manages and hosts the user's identity. User identification in applications that are deployed in a private or hybrid cloud, however, often work with an identity which is placed or residing in the enterprise system. This could be a Windows domain server, for example. When it comes to handling identities on the user side, convenience is very important. So let's talk about single sign-on next. Application developers can provide seamless access for their enterprise users by implementing single sign-on, SSO, and/or federate identity mechanisms. This could be an alternative authentication mechanism to the mechanisms we have discussed above. Once implemented, a user only needs to authenticate himself or herself once against the enterprise environment to use the cloud application without the need to re-enter his or her credentials again, which is often desirable from a usability perspective. This works because a trust relationship between the enterprise and the CSP will be established, which allows the cloud application to validate a user's authentication by receiving a token from the enterprise. If you want to develop an application with rather high security requirements, there is no way around multi-factor authentication. Multi-factor authentication, MFA, is an authentication mechanism that combines more than one verification method to add a second or third layer of security. MFA works by requiring at least two of these verification methods for successful authentication. Something you know, a password for example. Something you have, a smartcard or a phone, for example through a text message token. Something you are, biometrics. A sample authentication with MFA looks like this. You first authenticate with your username and your password. After the first authentication step succeeded, you get a phone call or a text message to one of your trusted devices with an additional piece of information, like a PIN code. Now, the application asks you in the second step of the authentication to supply exactly this information. Only if both steps have finished correctly, the user is authenticated. In a cloud-based environment, there is one role which is more promising for phishing than any other. Successfully phishing an admin or operator of a cloud service is extremely beneficial for an attacker, since a successful attack can lead to a broader cloud service compromise. Therefore, using multi-factor authentication is essential for these roles. Compromising MFA is a significant challenge for an attacker. Even if the attacker already has stolen the password, it is useless without having access to the trusted device. Many consumer-grade cloud services have therefore already started to rely on multi-factor authentication as well. Also in cloud applications, good access control mechanisms are only worth half as much without having role-based access control mechanisms, RBAC, applied. With RBAC, it is possible to only allow different user groups access to resources, according to the need-to-know or least privilege principle. Building on these, an additional proper logging is needed to still detect malicious users and identify security incidents through privilege misuse. Once we have a proper identity and access management established for our cloud application, based on this, let's discuss data encryption and key management. Encryption is the most pervasive technology to protect sensitive data and can be implemented in different ways. To encrypt data which moves within an environment, data in transit, the data is normally secured via secure communication protocols such as TLS, SSL, or IPSec. Compared to data which resides in an application or infrastructure, data-at-rest, the encryption scheme depends on how data is being created, processed, and stored within an organization. Data-at-rest solutions are often based on symmetric cryptography. Within an application, it is necessary to encrypt a file or database entries. In another scenario, it could be a requirement to encrypt data when it is written to storage, when data leaves the storage, or to encrypt the whole disk. Given this diversity of scenarios, multiple solutions must be applied within an application or within the environment. As a security architect, the key point here is to consider which types of data in terms of data in transit or data at rest should be protected under certain use cases, for example, when leaving a system or trust boundary. Remember that the need for encryption always depends on the application scenario. Nonetheless, let's explore the crypto elements here a little further. Those of you who have watched our Crypto 101 training already know that the best encryption mechanism is useless without proper cryptographic key generation and management. This is particularly the case for data-at-rest solutions, where the loss of the key results in an encrypted dataset which can no longer be decrypted, or the compromise of the key, which results in exposure of sensitive data. An appropriate key management solution can help to handle compromised keys and assist in the key generation phase to decrease these concerns. For secure communication protocols, key management is built into the protocol. The exchange of the symmetric encryption key is secured with asymmetric encryption. The basis of asymmetric cryptography are certificates, which are managed via a public key infrastructure, PKI. If you want to get more details on understanding critical elements of crypto, we recommend to watch SAFECode's Crypto 101 training. To sum up data encryption and key management, there are some considerations a developer or architect has to think about. Ensure that all encryption and key management functionality complies with the import and export regulations for the countries the application is developed for. Ensure that the encryption and key management solution accommodates for any organizational or governmental requirements. Choose strong cryptographic algorithms without known vulnerabilities and appropriate key lengths. Choose an appropriate encryption solution. After having explored cryptography for identity and access management, let's look now into the next section of shared responsibilities of application-level controls and application programming interfaces, APIs, as those are another important but potentially weak spot. Cloud environments also offer APIs to the developer to use different kinds of services. Unlike common web application APIs, cloud APIs are developed to be used mainly by other cloud services. Therefore, the usage needs to be limited. As a matter of fact, A lot of cloud services forget to do that. As a result, a lot of services can be accessed from the internet by the end user, which weren't meant to be accessible by this group. Developers of cloud services need to be aware of this problem and take action to protect their cloud services. Similar to rich client applications, most cloud applications can be separated into different layers. When implementing data validation, it is important to keep track of the data flows inside a cloud application. A back-end worker should not need to do data validation if it is ensured that validation has happened at an earlier point already. Data validation can be a challenge in cloud applications due to different layers and very complex data flows. A good way to prevent incomplete data validation or accessible API services is to do an extensive threat modeling during the design phase at the beginning of the development. Generally speaking, using a secure development lifecycle model is essential for cloud-based applications and improves the quality and security of your cloud application drastically. Another problem, especially with web-based cloud applications, are shared domains and the same origin policy. Let's talk about the same origin policy first. The same origin policy makes sure that a website can only be manipulated by scripts which originate in the same website. Therefore, a different website can't change content of your website. This is basically a good thing. Nevertheless, if you host two different applications on the same cloud provider, those applications can't exchange information using JavaScript. It is possible to increase the execution domain of JavaScript to the level of your cloud provider, therefore allowing the execution of all scripts originating at your cloud provider. Unfortunately, this means not only the scripts from your application can run. It allows every single application on the cloud provider to manipulate your content. This is commonly known as the shared domain issue. This problem does also appear for other elements, such as HTTP cookies. The scope of a cookie is bound to the full qualified name. Developers can change the qualified name. Furthermore, a similar problem appears with HTML5 local storage mechanism, which is also bound to the full qualified name. Some browsers allow websites to change the qualified name for the storage mechanism to share data. This can lead to data leakage. A good way to avoid this is to get a unique domain name from your cloud provider. By doing this, the possibility that you share your application with someone is significantly reduced. Additionally, it is a good idea to check for shared domain references. If it is not possible to receive a unique domain name, it is also possible to tie a TLS certificate to your domain name. Many cloud providers offer only one TLS certificate, which is shared between several cloud customers. But by using your own, you can separate your domain from the other customers. One of the main issues of network controls are denial of service attacks. In a cloud environment, denial of service attacks can be executed through different attack vectors, as already described earlier in the first part of this training. Therefore, it is better to keep an application simple and use defense techniques like load balancing, traffic management, or scaling. When using a SaaS solution, the customer is abstracted from the network infrastructure, therefore not being able to manage and secure the network controls on his own. Most network control is done by the service provider. When virtual machines are used, it is possible for customers to configure network-level services. In an IaaS solution, the customer shares responsibility with a service provider to deploy, manage, secure, and configure the networking solutions to be implemented. To summarize, depending on the type of cloud service you are relying on, your CSP possibly offers mitigation against network denial of service attacks already. One of the core concepts of cloud computing is multitenancy. This concept offers the possibility to have several active customers on a single cloud provider without sharing any data between the customers. 5 rules apply for multi-tenancy systems. No customer should be able to know the identity or existence of any other customer. No customer should be able to access data of any other customer. No customer should be able to execute an operation which affects the availability of any other customer. The configuration of a customer should be independent of any other customer. Provisioning and dismissing a customer should be strictly separated. From the point of a cloud provider, the design principle is logically separated, physically shared. For each customer, it may look like he has his own system, while in fact, he shares his system with other customers. As a result, it is very important for the cloud provider to protect the hardware against attacks. Cloud providers normally group customers with similar needs onto the same physical devices and systems. Therefore, customers who need data storage tend to share a system with other customers who need data storage. Most applications running in a cloud environment are aware that they are running in a multi-tenancy environment. Therefore, those applications are developed to use multi-tenancy infrastructure. As a result, most cloud applications store all data in a single database. Two concepts are used in order to share data in such a database. Shared schema. Each table uses a tenant ID entry which defines who the owner of the table entry is. If the application insufficiently checks the tenant ID, it creates a vulnerability. Separate schema. All tables of a customer are added to a single schema. The schema is set for the first time after the user account is created. Therefore, the database can access only the data the customer owns. Obviously, the usage of a separated schema is recommended. A well-known concept for host infrastructure are trusted compute pools, TCP. TCPs are logical or physical groups of computing resources or systems in a data center that share a security posture. These systems provide verification of the boot and runtime infrastructure, which are also known as platform trust attributes. This critical data, sometimes also called measurements in this context, is stored within a trusted location on the system, normally a TPM, and can be validated via a verification service. The attributes can be used to determine the trust of a given system and therefore assign applications to the system which meet the attributes. TCP is used to separate between trusted systems and untrusted resources, which results in the separation of higher value, sensitive applications from commodity applications. Let's look at a visualization of how TCP works on the next slide to understand this concept better. This diagram shows a sequence to determine which application can be deployed to which system. In the steps 1 through 3, the platform trust attributes are read from each TPM. In step 4, the values from the TPM are collected from the system by an agent for verification. In step 5, the agent sends the information to the attestation service, which verifies the trust measurements. The agent can then use the results from the attestation service to decide which systems meet the security constraints of each application. In step 6, the applications can be deployed to the systems. You should ensure that your cloud platform provides trust measurements and the APIs needed to request and verify the measurements of the infrastructure your application is running on. Furthermore, make sure that your application runs on the required trust measurements by verifying them as part of initialization or as separated function prior to launching your application. We've discussed a lot of virtualization elements so far. Now, let's go back to something more concrete, the physical security element of cloud computing. For every IT system, considerations of physical infrastructure security and facilities need to be done. In the case of cloud computing, these considerations apply too, but quite often the infrastructure will be owned by the cloud provider and not the customer. Therefore, it is the responsibility of a cloud service customer to get assurance from the provider that his security needs are met. As a customer, it is advised to rely on cloud service providers that are ISO 27001 certified. Even though ISO 27001 is not a specific cloud security standard, the principles for physical and environmental security can be applied to the providers of cloud services and data centers. Nevertheless, let's take a short look at all relevant ISO standards for cloud security. The ISO 27001 is a specification for an information security management system, or short, ISMS. An ISMS is a framework of policies and procedures that includes all legal, physical, and technical controls involved in an organization's information security risk management processes. Nevertheless, ISO 27001 defines a broad range of policies and technical controls and is hard to use for a cloud environment only. Therefore, at the end of 2015, ISO 27017 was released, which specifies the application of the ISO 27001 standard to cloud services. This means the ISO 27017 suggests additional security controls for the cloud, where ISO 27002 does not adequately cover this area. Last but not least, the ISO 27018 is a standard which is handling the protection of privacy in the cloud. On one hand, this standard augments the existing ISO 27002 controls with specific items for cloud privacy, and on the other hand, it provides completely new security controls for personal data. As a result, a cloud provider should at least implement the 27001 standard. Having a provider which relies on the ISO 27017 standard would also be a sign of appropriate security management processes. If you are interested in handling personal data and want to make sure they protect this data in the most appropriate way, look out for ISO 27018 as well. As customers transit their applications and data to the cloud, it is really important that the level of security provided in the cloud environment is at least equally or even better than the security provided by the IT environment in the organization. To achieve such a high level of security information, security requirements must be defined. These requirements allow the customer to evaluate and adjust the security of the cloud environment and help him to mitigate cloud-specific risks. At the end of this training, we would like to give you a bit of guidance to take with you on how to assess the security of an application transiting into a cloud, or the security of a cloud solution overall. There are a lot of critical questions that cloud customers should ask themselves and their cloud providers during each step of a so-called security assessment. In this section, we will only cover the most important ones in each of the 10 steps. Step 1. Ensure effective governance, risk, and compliance processes exist. In the first step, the customer needs to define the scope of his processes by asking the following questions. What information security and privacy standards or regulations apply to the cloud customer's domain? Does the customer have governance and compliance processes in place for the use of cloud services? Does the provider have appropriate governance and notification processes for their services consistent with the customer's requirements? Is there a risk related to data location? Step 2. Audit operational and business processes. In the second step, the customer should ask the cloud provider at least the following questions. Does the provider have mechanisms to report to the customers both routine and exceptional behavior related to its services? Are all appropriate events and actions that have security implications logged? Is there an incident reporting and incident handling process that meets the needs of the customer? Step 3. Manage people, roles, and identities. In this step, the customer should clarify the following authentication-related topics with the cloud provider. Do the provider services offer fine-grained access control? Is multi-factor authentication supported for provider services? Can the provider give reports for monitoring user access? Step 4. Ensure proper protection of data and information. In Step 4, the customer has to validate the protection of data by answering at least the following questions. Is there a catalog of all data assets that will be used or stored in the cloud environment? Is there a description of responsible parties and roles? Have appropriate confidentiality, integrity, and availability measures been applied to data used or stored in the cloud? Step 5. Enforce privacy policies. Similar to the previous step, the customer has to validate the proper protection of the data stored in the cloud-based application by answering questions. But this time, the data asked about is a lot more critical and sensitive. Is Pi going to be stored or processed by the cloud services? Which data protection laws and regulations apply, given the industry and the locations in which the customer operates, or the locations where the provider stores the data? Do the provider's services have appropriate controls in place for handling Pi? If there is a data breach, are responsibilities for reporting and resolving the breach clear, including priorities and timescales? Step 6. Assess the security provisions for cloud applications. In Step 6, the customer should clarify if the cloud environment complies with the defined security requirements and standards by answering the following 2 questions. Based on the cloud model used, is it clear who has responsibility for the security of the applications, customer, or provider? Does the application make use of appropriate encryption techniques to protect the data and the user's transactions? Step 7. Ensure cloud networks and connections are secure. In Step 7, the customer should ask the cloud provider questions regarding network security topics. Which abilities does the provider have to deal with denial of service attacks? Does the provider's network have intrusion detection and prevention in place? Does the network provide the customer with logging and notification? Is customer network access separated from provider network access? Step 8. Evaluate security controls on physical infrastructure and facilities. In Step 8, the customer should ask the cloud provider about the physical security controls in use. Can the cloud service provider demonstrate appropriate security controls applied to their physical infrastructure and facilities? Does the service provider have facilities in place to ensure continuity of service in the face of environmental threats or equipment failures? Does the cloud service provider have necessary security controls on their human resources? Step 9. Manage security terms in the cloud SLA. In Step 9, the customer should take a closer look at the service level agreement and the included security terms. Does the cloud service agreement specify security responsibilities of the provider and of the customer? Does the service agreement have metrics for measuring performance and effectiveness of security management? Does the service agreement explicitly document procedures for notification and handling of security incidents? Step 10. Understand the security requirements of the exit process. In the last step, the customer should clarify the terms of ending the contract with the cloud provider by asking the following 2 questions. Is it stated that all cloud service customer data is deleted from the provider's environment at the end of the exit process? Is cloud service customer data protected against loss or breach during the exit process? As the topic of bringing applications into the cloud securely is a rather complex one, we hope you got an idea throughout this training what the most critical points are when relying on cloud environments. Remember, there are always shared responsibilities between you as a cloud service customer and the CSP. The question who is responsible for doing what always depends on the service model that you have chosen. Finally, make sure that before choosing a CSP, you should assess his security posture. Remember the assessment guidance that we presented in the end. Here we list a few links and resources that we have used for creating this training for you, that you might want to explore to increase your understanding of cloud computing, its applications, and how to use them securely. Thank you for taking this SAFECode training course.